Now, to give you a bird's eye view of the practice test for Module 2, there's just 16 questions. And I did take the practice test for Module 1 already. And I did do a review of that. But looking at the scores, most people did rather well. But for those of you who are going to start, let me give you a little preview here. So we're going to start the test. And where I'm not going to actually give you the answers, I'm going to give you the strategy for getting to the answers. So there's question 1. I would suggest you make a little T-chart to organize your data. Then you're going to put, for your X value, a 3 wherever there's a B, and then later a 0. And once you do that substitution and calculation, that's where you put your answers. So the substitution would look like this. You're going to raise 3 to the second, which is 9. Multiply 3 times a negative 18. This will be a negative value, and group like terms. This one's going to be easy because this term and this term are 0. All right. Strategy for something like this, since there's a plus between them, just put them in like term vertical columns. And you're just going to add these up, and that's what your answer will be. So what we would do here we're multiplying a binomial by a binomial, so we're going to use the FOIL. So this times this will give you this term. Then your outers gives you this term, and that's going to be a negative something. Your inners give you a positive something, and then your last will give you a negative something. And these two terms are like terms, so you will combine them and end up with a trinomial. In this example, we're going to be squaring a binomial, and the technique, you remember, is to square this first term. This term is squared. Multiply these two terms together. It'll be a negative something, and then double it. It's going to be a negative sign there. And then we square this term, and we end up with a perfect square trinomial, and later we'll factor that too. Now for this one, they want you to factor it, and you have the number part. And remember, you're going to put a parenthesis. And what's the greatest number factor you can take out of each term? Well, you can see you take a 3 there. This is going to be a minus there. Now for the letter part, r to the 4th, r to the 3rd. The greatest you can take out of both is going to be r to the 3rd. And then we have s to the 2nd, s to the 3rd. So the greatest you can take out is s to the 2nd. Then we'll let you fill it in. Gave you a hint on this one. In this example, they're telling you they want you to factor by grouping. It's 4 terms. We want to take something out of the first 2 terms and end up with a similar factor out of the next 2 terms. So here, out of the first 2 terms, we did one in class like this yesterday. You take out an x squared. It's the greatest thing you can take out of both terms. And then here, I believe we could take out a positive 8. And we'll leave the rest to you. This is a strategy. So for something like this, where we're going to find the zeros using the principle of the zero product. We have to put this in standard form, so I just move that over to the other side, and it just changes its sign. Then I'm going to factor this, and I'm taking a 3x out of each term, and I get this. So now what I'm going to do is take each of these factors and equal it to 0 to get my solution set. And we'll leave that to you. Now, for something like this, is it in standard form? Yes. Are there any common factors? Yes. So we're going to factor out the common t. So then we get t squared minus 2t minus 48. So we then put two sets of parentheses. We're going to put a t there and a t there. Now notice your third sign here is negative. So one of these must be positive and one of them must be negative. And we'll let you do this last part. This is a strategy. In this example, notice we have a factor times a factor equals a negative 8. So was this in standard form? No, because in order to be in standard form, this would have to equal 0. So what's the strategy here? Well, we have to first FOIL this and get x squared. Now my outers are 5x, my inners a negative 1x, so this is going to be a positive 4x, and my last are a negative 5 equals 8. Now I have to integrate this 8 onto this side. Now when we do that, and by the way that was a negative 8, be careful of your signs. So a negative 8 on this side, this becomes a 3, positive 3. And now that's in standard form. So remember, if it's factored and it doesn't equal 0, you can't use the principle of the zero product. You have to FOIL this, integrate what's on the other side, so eventually you put it in standard form. Now you're going to factor. Each will equal each factor to 0 and get your solutions. Okay, and looking at something like this, it's in standard form. There's no common factor. So the next thing you do is put two sets of parentheses. And you know you're going to have a q there and a q there. And you'll have a t there and a t there. Now, since there's a negative sign in the middle and your third sign is positive, both of these have to be negative. So now you're looking for possible factors. So as you think of 20, 1 and 20, 2 and 10, 4 and a 5, and you could reverse them also, but I believe those are the ones. So a 20 and a 1, 20 and a 1. Again, you're going to have to play with this, as I will, but this is the strategy. Trial and error. Guess and check. Now that last one was factorable, and it was 5 and 4s, to give you a little hint. Okay, let's take a look at this one. Again, we're finding the zeros. It's in standard form, but I can factor out a t. So I go t times 3t squared plus 11t plus 10 equals 0. Then I have to factor this. And since this is prime, we know that's going to be a 3t, and this will be a t. So our 10 now is going to be a 1 and a 10, or a 10 and a 1, or a 5 and a 2, or a 2 and a 5. So this is the guess and check part. Then you're going to equal each of these factors to 0 and get your 3 answers, because again, this is an equation to the third degree. And here we're asked to factor this. Well, again, there's a common 6. And we end up with the difference of perfect squares, which always factor into their conjugates. Well, I don't want to give away too much, but again, this is the difference of perfect squares, and 256 is a perfect square, 16 times 16. So this will factor into its conjugates, and then one of these, which is a negative one, is still the difference of perfect squares, which will factor into its conjugates. So that will be the answer. Now, for this one, again, you're solving it. This is the difference of perfect squares that will factor into its conjugates, and then you use the principle of the zero product, and you can almost put the answers right there. So a hint on this one would be to, you see s to the third, and they want you to factor it. Well, this is divisible by 3, and this is divisible by 3. So once you get this, then you're going to use that recipe for factoring the difference of perfect cubes. This sign goes here, opposite sign there, and then you follow the pattern. Okay, for our last question, we have this, and 6's here, so that's divisible by 3. So this is the difference of perfect cubes again, where the recipe calls for parenthesis of 2, and this middle sign goes here, opposite sign there. And I'll give you a hint. This is, if you take the exponent and divide it by 3, you get c to the second. And this is a perfect cube. This will be 5, g to the second. And then you do your recipe over here, and that's the answer. Okay, well, good luck on this. Hopefully it's helpful to you. It's just under 14 minutes. As a little postscript here, when I looked at that, that looked like a T to me, but I see it's actually an F. So I put it in the correct factoring, but they counted it wrong. So for something like that, I would override the system and give you full credit. All right, it's just a little small and hard to figure out. Okay, done.